Great. I'm really glad to be able to come and share this ongoing research with you all. I want to recognize my colleagues, Mara Carpinelli, Brian Chu, and Kevin Chu. Kevin is at GitHub. This is a collaboration between LinkedIn and GitHub. All right, so I really don't need this preface slide for this audience. I do for some other audiences, but generative AI is receiving a lot of deserved attention. I live in Pittsburgh. Actually, I live in a small, sleepy suburb of Pittsburgh. And about a year ago, this was painted on a wall about a 2-minute walk from my house. So it reached even the sleepy suburb of Sewickley, Pennsylvania. Generative AI and AI in general loves you. And the context that we're going to look at is GitHub Copilot. And GitHub Copilot, you probably are aware, but just to set the stage here, is a product that can write and debug code, which are core skills for software engineers. And GitHub Copilot is this really important tool. So I have to admit, I work for LinkedIn. LinkedIn is owned by Microsoft. GitHub is also owned by Microsoft. It's all part of the family. Nonetheless, I use this every day in my work. I use GitHub Copilot. It's fantastic embedded code. If you don't use it, you should look into it. There's my plug for that. But really, this is really, I feel that it's a powerful tool to enhance productivity of software engineers. And it's had some pretty rapid adoption. There's a survey, 88% of developers have a higher perceived productivity when using it, and faster work on repetitive tasks, et cetera. I don't have a slide in here because it wasn't approved in time from the GitHub side, but there's also been so I won't give exact numbers, but pretty rapid adoption of GitHub Copilot among its GitHub clients. And so these enterprise licenses for firms that hire many software engineers. And what we're going to do is try and move beyond the productivity enhancement impact measures, which we've seen presented here before at this conference, which sort of are really important, but we're going to say, all right, what does that end up meaning for the labor market? So we're going to look at lots of outcomes. And the goal here is just sort of an exploratory analysis to really understand what might be happening along several different dimensions. So we're going to look at skills and employment. And in all of them, we're going to look at sort of the demand side, the supply side, and equilibrium outcomes. So for example, for employment, we're going to look at job postings. That's going to be, are firms that adopt GitHub Copilot, as a result, going to have more job postings, higher demand for software engineers, or less? And what type are they going to have? And for the skills, I think we have some firmer hypotheses about what we expected to see. This sort of increase in skill adoption for programming skills for those that use it, and the firms maybe will start to increase demand for non-programming skills of new hires, given they know that this productivity enhancer tool will help with the coding side. But for the employment, it's a lot more uncertain what might happen. There are sort of some trade-offs that might happen as the productivity of software engineers goes up. Our sample, we're going to use data from both GitHub and from LinkedIn. For the GitHub side, we're going to be using the data on firm licenses of both the GitHub enterprise product and GitHub Copilot. And from LinkedIn, we're going to have all of our outcomes, our control variables, everything about the labor market that we can capture. LinkedIn data is actually particularly salient here. For software engineers, this is the job market, the primary job market source. That's where job postings happen, that's where hiring happens, that's where people belong, have their memberships, et cetera. And so we're able to have a lot of confidence in the penetration of that data into this market and understand what we're going to see. We make some decisions along the way about how we merge, how we filter, construct the sample. We do a bunch of sensitivity analysis. Sort of spoiler alert, it actually doesn't make a difference. No matter what we do, the main story sort of shines through. So with this, we're going to use Callaway-Santana's Diff model. There's all of these new models, as you know, for the difference in difference. And we felt that this one was the best suited for a number of reasons. So there's lots of assumptions that go into diff models, including Callaway-Santana's. for example, the irreversibility of treatment. So that's specific to the Callaway-Santana model. Some Diff and Diff models don't require that. Just generally two-way fixed effects models allow for treatment to turn on and off. In our context, we actually kind of like this assumption that treatment is irreversible. On the one hand, we see that most firms that adopt GitHub Copilot don't stop using it. They are 96% probability of having it next month. The vast majority, even 1 year later, are still using it. But also, we think there's a lot of reason to believe that even if sort of the treatment turns off, that the impact could still be felt by the software engineers and by the firms itself. This connects to, for example, what Eric was talking about yesterday with the call centers. When you have the power outages, right? The call center employees that used the generative AI were still more productive. Other assumptions as well, we can get into those, but generally the rest are pretty standard for Diff and Diff models, and we're going to do the best we can. We're going to hope this points in the direction of causality, but again, we're kind of making the claim that this is an exploratory analysis for a number of reasons, one of which being sort of that we are just looking at tons of outcomes, and we're just sort of looking around to see, hypothesis formation. What can this tell us about what's happening? So what do we find? Here's for our main sample, the main results. As I talked about, we had those different, there's the, yeah, can you see that red dot? For skills, what do we find? Well, we only find a statistically significant result for the average number of non-programming skills of new hires, and that's positive. So what we see is when firms adopt GitHub Copilot, the new hires that they do make have a higher number of non-programming skills on the platform. So the skills are measured by, on your profile, you can enter the skills that you have. And there's thousands of potential skills. They can be all sorts of things, but we put them into these buckets of programming and non-programming, as well as some others. That makes sense to us. This was one of our hypotheses we had, that as the programming skills became augmented by generative AI, by GitHub Copilot, that firms recognizing that would put a higher premium on the non-programming skills of new hires, realizing that whoever they hired would be able to have the assistance of GitHub Copilot for the programming part. Interestingly though, we see this increase, we don't see a decrease or increase, either way, of the programming skills of new hires. So it's not like they're hiring people that have fewer programming skills, just more non-programming skills. In this sample, demand, we don't see anything. Supply, we do see. This is an interesting one. We can look at the job views and applications of current software engineers. So if I'm a software engineer at LinkedIn, we get GitHub Copilot. Does that increase, decrease, or not change my likelihood of looking for external jobs, viewing or applying for them? And for the applications, we didn't have a statistically significant result. That's a rare event, so there's a little more noise. But the views, they view fewer things. This might be a story of them being happier at their current position because of GitHub Copilot. It might be other things, but I thought that was interesting. This is the other main important finding over here, though, the new hires. What do we see? A lot of the worry about AI is the displacement of workers. And we find that for this specific tool and for this specific population, that's not the case. In fact, it's the reverse. We find that GitHub Copilot leads to increases in the number of new hires, both the likelihood of making any new hires that period and the number of hires. And it's really happening in terms of the individual contributors, not management, but the actual software engineers that are going to do the coding. We see an increase at that level, both the entry level and senior level. In terms of the point estimate, so there were actually 70 outcomes we looked at here. So lots. These are sort of summarized here. These are the 6 that were statistically significant. And here we can see sort of the percent increase over the control. So for example, the average number of non-programming skills new hires have, it's a 13% increase over the control group, the treatment effect is. So relatively large. And similarly for the increase in hiring, we see this ranging between 3, 4, 5, 6%, let's say a 5% increase in the number of new software engineer hires that they have. And these two outcomes, both the hiring of new software engineers that are entry level, extensive margin, and non-programming skills of new hires. I said we did 70 things. You might start to worry about multiple hypothesis biases from all those tests. If we use the Benjamin-Hochberg multiple hypothesis correction, those two remain statistically significant even after the correction. Event studies of them show sort of that it's not a one-time blip, but sort of it looks like an increase. There's a lot more noise at the end there because there's fewer firms that far out of it. We do a number of sensitivity checks in this process. And I think the most interesting ones to me are where we look at the variation in the intensity of treatment. So we can see how many GitHub licenses a company has and how many Copilot licenses they have. And if we take the ratio of the Copilot to GitHub licenses, we can see sort of the penetration of the treatment. Do 50% of your software engineers that use GitHub have Copilot? Do 90%? To 5%? And so we can split that in half, the high dosage versus low dosage. And we can compare either high against low or high against everyone and include sort of low as part of the control group to say, hey, I think the split was somewhere around 20% was the median that we split on. So if you have more than 20% of your GitHub licenses that also are GitHub Copilot, you're a high dosage treatment, and compare them against each other. And what we find is that the results are very similar. All the main findings that I've actually said out loud remain true in either of those alternative specifications. And we actually find some additional things that are statistically significant, which I think are interesting. We find that existing software engineers add more skills from treatment when we do some of these alternative specifications, but fewer industry, business, and soft skills. Those are non-programming skills generally. We also find an increase in the number of job postings for software engineers that don't have a degree requirement. This is something that LinkedIn has paid a lot of attention to, is like thinking about how different jobs, whether or not they require degrees, as we move towards skills-first hiring. And so this was an interesting little nugget there, saying maybe GitHub Copilot, this augmentation of people's skills, helps software companies move a little bit away from using the strong signal of a degree. So in conclusion, instead of leading to job displacement of software engineers, we find evidence of increased hiring. 3.2 percentage point higher probability of hiring new software engineers each month. And conditional on hiring at least one, increase of how many they hired, 5.8%. Sorry, that should be 5.8. And that's happening primarily among the individual contributors. And we also, as I've just mentioned, find this for a specific specification, evidence of more job postings for software engineers with no degree requirement. Meanwhile, existing software engineers at GitHub Copilot firms view 3.3 fewer external job postings. And so this might fit into that narrative of sort of the workers becoming more productive and happier from the products. This is all conjecture. We're not able to dig into sort of what exactly is happening there, but we found it really interesting. We also find some evidence of the shift in skills demanded, used, et cetera. 13.3% more non-programming skills among new hires of software engineers, and evidence of skill changes, 27.7% increase in the share of software engineers that are at the company already, adding at least one skill to their profile in a given month. And fewer non-programming business, soft, specialized industry skills. So for us, I think that this is encouraging about how this segment of the economy is being impacted, at least in the short run, over the few years by this new technology, and gives us sort of a look at what this augmentation of their skills might mean for the software engineers generally. Thank you.
Do we have any questions?
Thank you. This is a very interesting study. So you focused on the new hires, and
We looked at both. So we looked at new hires as sort of an equilibrium outcome, but we also looked at job postings and the existing software engineers at the company, software engineers.
Right. So is the claim that the overall market for the number of software engineers is expanding because of this? Could we say that, or could there be some substitution going on here?
Yeah, no, that's a good question. I'm not sure. I think we'd have to dig into that. There could be substitution. So we're measuring sort of the difference between the Copilot and non-Copilot. We're not looking at sort of the overall, and that might be harder to measure because of the sort of the overall macro trends, not being able to separate it out from the occurrences that happen for everyone. But it's an interesting thing for us to think about.
Are there any other?
Have you looked at, I'm sure you have, the selection bias of like, if I'm a firm adopting Copilot, the chances are I'm in a growing industry, early adopter in tech, so I will be hiring more and growing versus the rest of the market?
Yeah, so we've looked at it in one way, which is, so we, in our model, are including not yet treated as part of the treatment group. And so some of that, and this is part of our next step, is to really dig more concretely into that. And so the idea is there might be random variation in when a firm adopts GitHub Copilot based on when their contract with GitHub expires. Sort of when they're renewing one, they might add on the other. And so we think it'd be interesting to sort of really leverage that difference. I mean, it's included already right now, but not specifically that. We're also including all the control. Other than that, I mean, this is part of why we call it exploratory analysis. I mean, we're using diff and diff, we're using doubly robust, but it's still there's selection bias.
One more clarification.
Sure.
Are you also distinguishing between enablement of the license and actual usage of the license? Because we can just turn it on for the whole department, nobody might use it.
Yeah. So this is not distinguishing between that. It's just looking at the licenses held. But I think that'd be interesting to see if we can observe that. I mean, I'm sure GitHub has that in their data.
Has it?
Yeah. All right, thank you.
All right, thanks.
Yep.